Welcome back to geometry. These are a couple of reminders of finding areas that are composites. Go ahead and pause the tape and try these, please. Okay, we want to start with how do we find the area of the shape we're interested in. In the first one, pi r squared, it's just a circle. In the second one, I need to come up with the area of the rectangle and subtract the white space, which is the area of the circle. In the third one, I have to find the area of the circle and subtract the area of the triangle. So the first one, I just number crunch, 9 pi or 28.3 centimeters squared its area. On the second one, the circle is going to have a radius that is half of this one length of the rectangle, so it's going to be 7.5. I'm going to need that. Here we have the area of the rectangle base times height, and the area of the circle, calculating number crunching. In this one, the area of a circle, we do need to recognize the radius is 16. Pi 16 squared. Now for the triangle, what I did was took these two pieces and made them a square. If this is 16, this is 16, this is 16, I could have also done 1/2 times 32 times 16, because 32 is the distance all the way across, and number crunching. So we're looking for the surface area of a cone now. And in the cone, we have two parts to the cone. The first one is the base, and it looks like a circle. And then in order to make the cone shape, I have to take a sector, and it really is not going to matter what the angle is here, because we're going to find this length right here, which is the circumference of the circle, times this part here is not going to be the actual height. It is called something a little bit different. Sometimes we use S. I tend to use a cursive L for this one. It's called slant height. I need to find both of those areas, the area of the circle plus the area of the sector. So this ends up being our equation. This is the area of the circle. We call that the base. And this one, this L is usually in cursive. That way it doesn't look like a 1. And that's called the lateral area. So our steps are, make sure that we have the radius and the slant height. Gotta have those. We will have more complicated problems in a little bit. We substitute those in and number crunch, making sure we have our units. So in this particular case, when we do all our calculations, order of operations, 282.7, our units for area are squared, so inches squared. Those are the main steps. So here we have, given our slant height, like I said, a cursive L, and our radius, since we have those two, we've got the equation ready to go. We substitute in all of our information into that, the radius and the slant height, and do some number crunching. Sometimes I do the numbers in front of pi, combine those before I calculate times pi, 201.1 inches squared. Next problem, we have radius and slant height. We plug those in and number crunch, 681 meters squared. I tend to do the calculations in front of the pi because those ones I can kind of tell if I'm on the right ballpark that I do as the last step multiplied by pi. Here are harder problems. In these harder problems, what happens is they don't give you the slant height. They give you the height instead. It's not what I want in the equation. So I have to find the relationship between them, and it is the Pythagorean theorem. So in the Pythagorean theorem, base times height Here's the base, radius squared. Here's the height. Height squared equals the slant height squared. The common mistake is plugging in height when you needed slant height. So here we have an example, and I don't have L, I have H. So I'm going to plug those into the equation. It doesn't matter which side these parts go to, so it's perfectly okay to have L squared first. And I have 12 squared plus 5 squared. Calculate the squares, add, and this one happens to be a perfect square, 13. Once I have that, now I'm ready to substitute those. Now I'm ready to substitute those in and number crunch. And again, I know 12 squared, I know 12 times 13. It's easier to do it that way, times pi last. There are times I'm not being asked for the entire thing. Sometimes you're asked for what is called the lateral area. Lateral area is the cone, not the base. So in that, I would usually pick, okay, I know the equation, it's got this, but I don't need the base. So what I do is I get rid of this guy here, and this is the only part that I need. It is called the lateral area, so sometimes we use LA instead of SA. So I still need to find the slant height. To do that, I'm going to use Pythagorean theorem. Notice that this is the diameter, not the radius, so I needed to plug in a 9. Number crunching that, I end up getting a slant height of 22.84. I am expecting it to be larger than either one of my other two numbers. Plugging that in and number crunching that, I get 1291.6 meters is squared because area is squared. Please make sure you're using slant height and radius. Radius, they could very easily give me diameter. Slant height, they could very easily give me height. Pythagorean theorem. Second thing to question, are you looking for the entire surface area or just the lateral area? With those in mind, your homework is on Google Classroom, and have a good day.